Hello everyone. Today we are going to solve the Leetcode question number 221, maximum square. Given an m cross n binary matrix filled with zeros and ones, find the largest square containing only ones and return its area. We are given an example here which has the list of ones and zeros. In this matrix we have two large squares which has only ones. We have one square marked in red and the other square marked in green. So the area of the square is 2 multiplied by 2 equals to 4. There is another example here which has two squares. So the area is 1 multiplied by 1 is 1. And there is another example which has 0. So the output is 0. I hope the question is clear. Now let's see how we can solve this problem. Let's take the example of the matrix that we saw in the question. As a first step, we have to initialize the first row as the current row. And we are defaulting the area as 0. We need to compare the first row with the previous row. Since the current row doesn't have a previous row, only for the first row, we are initializing a new row with zeros as the previous row. We will iterate from the second element of the current row to the last element. If the current row has a value 1, we will find the element in the left and the element in the previous left and the element on the top. We will take the minimum value of all the three values marked in blue and we will add 1. So the minimum value is 0 plus 1 is 1. We will change 1 with the value that is present in green. Now we will iterate to the next element which is 0. So we will move to the next element which is again 0. Once we reach the last element of the current list, we will calculate the area. The area is the maximum element of the current list to the power 2. So in this case, the maximum element is 1. So 1 to the power 2 is 1. So we are changing the area as 1. Now we are moving to the next list and we are repeating the same steps. We are iterating from the second element of the list. Since it is 0, we are moving to the next element and we are getting the smallest of all the three sides. In this case, the smallest is 0. So we are adding 1. So 0 plus 1 is 1 and we are replacing 1 with the element which is in the green. Now we are moving to the next element and we are checking the minimum element of all the three sides. The smallest value is 0. So 0 plus 1 is 1. We are replacing the element which is in the green cell to 1 and we are iterating to the next element. We are checking all the three sides. Here the smallest element is 0. So 0 plus 1 is 1. We are replacing 1 with the element in the green. Now in order to recalculate the area, we are finding the largest element of the current list and squaring the value. Here the largest element is 1. So 1 square is again 1. We are comparing 1 with the previous area which is also 1. So the new area will also be 1. Now we are moving to the next list. Here the value is 1. So we are checking all the three sides and finding the minimum value and adding it to 1. So in this case the minimum value is 0. So 0 plus 1 is 1. We are replacing 1 with the element in the green cell and we are moving to the next element and we are finding the minimum element of all the three sides. Here also the smallest element is 0. So 0 plus 1 is 1. We are replacing 1 with 1 in the green cell and moving to the next element. Now we are checking all the three sides. So the smallest element of all the three sides is 1. So 1 plus 1 is 2. Now we are changing the element in the green cell to 2 and we are iterating to the next element. We are repeating the same step again. Now we are finding all the 3 sides. The smallest element of all the 3 sides is 1. So 1 plus 1 is 2. We are changing the element in the green cell to 2. Now we are calculating the area. We are finding the maximum element of the current list. In this case, the maximum element is 2. So when we square it, it becomes 4. Now we are comparing this area with the previous area, which is 1, and taking the maximum value. So among 4 and 1, the maximum value is 4. So we are changing the area to 4. Now we are shifting the positions of the previous and the current list, and we are repeating the same steps. In this cell, the value is 0, so we are moving to the next element. Here also the value is 0, so we are moving to the next element. Here the value is 1. We are finding the smallest value of all the 3 sides. Here the smallest value is 0, so 0 plus 1 makes 1. We are replacing 1 with the element in the green cell, which is again 1. Now we are moving to the next element. Here the value is 0 and we are recalculating the area now. The largest element of the current list is 1. So 1 square is again 1. When we compare with the previous area, which is 4, the maximum area is 4. So the new area is again 4. We have to return the area, which is the output of this program. I hope the approach is clear. Now let's get into the implementation. As a first step, we will initialize area as 0. Area equals to 0. We will perform some operation only when the matrix has some list inside. If matrix, then we will perform some operations. I'm just mentioning it as pause for now. At the end, we will return the area. Return area. Now let's work on the main logic. We will initialize the previous list. Previous equals to a list of 0 multiplied by the length of one of the rows. Multiplied by length of matrix of 0. Now we will iterate through each row of the matrix. For row in matrix, we will assign value to the current row and we will change the string element to the number. Let's do that. Current equals to, I'm using list comprehension, 1 if character equals to string 1, else 0 for character in row. Let me change this to double equals to. Now we will iterate through each element of the current list from second element to the last element. Let's do that. For j in range of, second element is in index position 1 to the last element length of current. We need only the cells which has the value other than 0. If current of j has some values, we will find the minimum value of all the 3 sides. Current of j equals to min of previous of j minus 1, previous of j, current of j minus 1. We are checking the minimum value of previous left, previous value, and the left side element of the current list, and we are adding this to 1. At the end of the for loop, we are calculating the area. Area equals to max of the current area, comma, max of current row to the power 2. Now we are changing the current to the previous. Previous equals to current. Now let's submit it. The solution got accepted. Now let's talk about the time and the space complexity. We are iterating through the matrix only once, so the time complexity is O of m cross n, which is O of n. The space complexity is we are initializing couple of variables area and previous, and we are not using any extra space to change the value of the matrix. So the space complexity is O of 1. I hope you like this approach, and I'm sure you learned something new today, and I will see you in the next video. Thank you.